Good morning, Algebra. Well, it's morning for me. This is Algebra 1, Chapter 9, Section 7, Graphing Quadratic Inequalities. We are going to be sketching the graphs of quadratic inequalities. Do you remember doing linear inequalities? If so, this is very similar, however, more fun. So the first thing we're going to do is identify whether a point will be plotted inside or outside of the parabola. So we are given the graph of y equals x squared plus 2x minus 3. The first thing they want us to do is sketch the graph. I realize the parabola is already drawn for us, but let's actually make sure we remember how to sketch the graph of these parabolas. The first thing you need to sketch the graph of this parabola would be the vertex. So you're going to do negative b over 2a to find the x coordinate of this vertex, and then you're going to take that x value, plug it back into the original equation, and solve for y. Negative 2 divided by 2 times 1 would equal negative 2 over 2, which just equals negative 1. So the x-coordinate of our vertex is negative 1. Now, in order to find the y-coordinate of our vertex, you need to go back and plug it into the original equation. So we have negative 1 squared plus 2 times negative 1 minus 3, which would give us 1 minus 2 minus 3, which gives us negative 1 minus 3, which gives us negative 4. So the y-coordinate of the vertex is negative 4. So our vertex is negative 1, negative 4. And we can confirm that right here because the graph is already drawn for us. We are at negative 1, negative 4, and that is correct. The next thing you would need to graph your parabola would be some roots. So I don't really feel like using the quadratic formula. I know that in Chapter 9 you technically haven't learned yet how to do some factoring, but you already know how to factor, so why not factor? We already did Chapter 10. So I plugged the values a, b, and c into the discriminant quickly just to see if it is factorable. And so it would be 2 squared minus 4 times 1 times negative 3, which would be 4 plus 12, which would equal 16. 16 is a perfect square, so this quadratic equation is factorable. So real quick, I'm going to put C at the top of the T-chart. I don't really need to do this at this point because these aren't very large numbers. But negative 3 would go at the top of the T-chart. What are the factors of 3? Well, there's only 2 options at this point. It can be negative 3 and 1 or negative 1 and 3. Which of these are going to equal a positive 2? That would be this section, or this selection right here. So our roots, or the factored version of our quadratic equation, would be x minus 1 times x plus 3. And since we're looking for our roots, it needs to be equal to 0. So we will have x equals 1, x equals negative 3. And you can go back to the already graphed parabola and see that we are correct. I'll use blue. There's positive 1, there's negative 3. So there you have your parabola, and I'll do it in all sorts of crazy colors. There we go. Okay, now the next part of this example was to plot and label the points. I know you know how to plot and label points already, and so I am going to leave that done in the notes. So now you just needed to confirm whether or not these points fall inside or outside of the parabola. So let's look at point A, 0, 1. 0, 1 is definitely inside the parabola. B, negative 2, 3 is also inside the parabola, while the last point, C, 1, negative 3, is outside of the parabola. So when you are graphing these, and if you need to determine this, make sure that you are extending your parabola all the way to the edges of the graph. You want to make sure it goes all the way to the edge of the graph so you can be sure that you can shade properly, because we are going to be shading since these are inequalities. So we know that A and B are on the inside, and poor C is on the outside. So let's go down to these checkpoint problems. You are going to use these coordinates, plot them on this coordinate plane from example 1, and just tell me whether they are inside or outside of the parabola. So do that, pause the video, and come back when you're finished to check your answers. Alright, you're back. So here are the coordinates. I just labeled them starting with D, E, F, and G. So there are the coordinates. So if you come down, here are your answers. D is on the outside, E and F are on the inside, and G is on the outside of the parabola. See what I did there? Alright, moving on. Sketching the graph of a quadratic inequality. Here are your rules. The rules and steps for sketching the graph of a quadratic inequality are very similar to those of sketching and graphing a linear inequality. So if we're sketching a graph of the equation y equals ax squared plus bx plus c, that corresponds to the inequality. So it's not going to be an equal sign anymore. It's going to be some inequality symbol. We don't know which one yet. You are going to sketch a dashed parabola for inequalities that are less than or greater than. Dashed goes with less than or greater than, the same thing. And this will show us that the points on this parabola are not solutions. Just like open circle, closed circle, open circle shows that that value is not a solution on the number line. A dashed linear equation shows us that those solutions on that line are not solutions. And then for the parabola, if the parabola is dashed, any other point on the parabola is not a solution. You want to sketch a solid parabola for inequalities with less than or equal to or greater than or equal to show that the points on the parabola are solutions. Just like closed circle on the number line and solid line linear equation, these are solutions. Step 2. After you draw the parabola, it has separated your coordinate plane into two different regions. We can't necessarily call these half planes anymore because a parabola is not a straight line, but it is separated into two different regions. So you are going to pick a test point. We've done test point before. Your test point will typically be 0, 0, but remember, the only time you cannot use 0, 0 if it falls on the actual parabola. After you do test point, if the test point is a solution and it is true, you shade that side of the parabola. If your test point is false, you shade the opposite region. So let us graph this quadratic inequality. we have y is less than x squared minus x. We know right away that we are using a dashed line because it's a less than symbol. We also know this parabola opens up because a is positive. So the first thing we need to do is graph this. Now they're not leaving you any space on here anymore because they're expecting that you can graph them. So let's move over here and do the steps we just did in that earlier example to graph this quickly. So the first thing we're going to do is find our vertex, negative b over 2a. So you plug that in and you get the x coordinate of 2. Now we're going to go back and plug this in to the original. Which gives you 4 minus 8, which gives you negative 4. So what is your vertex? Your vertex is 2, negative 4. Ew. Oh my, what is happening? And if you look at the parabola, that is already finished for you. You can see that we are correct. 2, negative 4. There is your vertex right there. Now let's look at this quadratic equation. X squared minus 4x. That's all we're given. So I'm going to throw in a 0, because you can put 0 at the top of the t-chart. Why not? Put 0 at the top of your factoring t-chart. What makes 0? Anything. So I'm going to do negative 4 times 0, because that's my only option, because I need these to add together to equal negative 4. And they do. So we're going to do x minus 4, x plus 0. So what are my roots? X minus 4 equals 0, x plus 0 equals 0. So we have x equals 4 and x equals 0. X equals 4 and x equals 0. We are correct. And we know that this is a dashed line. I'll make them purple. Alright, and remember we need to extend our parabola all the way up to the edges of the graph so that when we shade, we know where we're shading. Okay, the test point they give us to figure out where to shade is 0, 1. Why are we not using 0, 0? We cannot use 0, 0 because 0, 0 is on our parabola, so we can no longer use it. We already know, because this is a dashed parabola, that 0, 0 is not a solution. So we are going to use 0, 1. We're going to take 0, 1 and plug that into our inequality. So we are left with 1 is less than 1 minus 4, and 1 is less than negative 3. So this is what we have here. Okay. So 1 is not less than negative 3. 1 is greater than negative 3. So this is false. This is false. So we need to go to the parabola and see where 0, 1 was. 0, 1 is right here. 0, 1 was on the inside of the parabola. So since this is false, all of the solutions inside the parabola are now false. So you are going to shade everything outside of this parabola. Everything outside.